Good morning, Phoenix class, and welcome to today's maths lesson. I can solve problems involving area. Okay, so what have we learned so far? We have learned that we can find the area of a rectangle by timesing the length of the rectangle by the width. So, for example, in the picture there, your rectangle is 10 centimetres long by 3 centimetres, so 10 times 3 is 30 centimetres squared. We also know that to find the area of a parallelogram, we'd times the base by the perpendicular height. Now, that's not the diagonal line, remember. Perpendicular means that it is a line that joins another line at right angles at 90 degrees. So as you can see from the purple parallelogram, that's difficult to say, on your screen, base is 8 centimetres and our perpendicular height is 3 centimetres. So 8 times 3 is 24 centimetres squared. Then, of course, the other thing that we've been practicing this week is finding the area of a triangle. So this time we will do the base times the height, or the perpendicular height, divided by 2. Again, it's not the diagonal side of your triangle. It is the height from the very tallest point leading straight down so it meets the base at right angles. So on that green triangle on your screen, you've got the base is 5, your height is 3, so 5 times 3 is 15. Because it's a triangle, so it's half of a rectangle, we divide that by 2, giving us the answer of 7.5 centimetres squared. Okay, let's have a look at our first problem. The garden has 2 paths that are perpendicular to each other. Can you remember what perpendicular means? It means that they are at right angles to each other, and you can see the right angles marked on the picture. Each path is 2 metres wide. What is the total area of the paths? Now, that looks quite complicated to start off, so let's break it down. First of all, what shapes are the path? We can see a rectangle there. So how big is our rectangle? We can see that it is 2 metres wide, and then it is the same height as the perpendicular height, and that's given to us. So that is 8 metres. So we know it's 2 metres in one direction and 8 metres in the other. Therefore, we can find the area. So we can say the area of the rectangle is going to be 8 times 2. Then we've got this other shape here. What does that look like? Yes, you're right, it's a parallelogram. So again, our parallelogram has a perpendicular height of 2 metres. And we can see the base of our parallelogram is 10 metres. Can you remember what the formula is for working out the area of a parallelogram? It's area equals base times perpendicular height. So let's have a look. There we go. That's our rectangle. So as we said, it's 2 metres in one direction and 8 metres in the other. So 2 times 8 is 16 metres squared. Now let's think about our parallelogram. So our base is 10, our perpendicular height is 2, 2 times 10 is 20. So we can add those up together. So that will give us an area of 36 centimetres squared. But can you spot something that we've done there? We've added those together, but we have an area in the middle that the rectangle overlaps the parallelogram. So we've counted that area in the middle twice. Can you see I've just marked it in green there? So we are going to have to work out what that area is so we can take one lot away. Because at the moment, we've included it in our parallelogram and we've included it in our rectangle. So it looks like it's a square to me because I can see that one of my sides is 2 meters and the other side is 2 meters. So 2 times 2 is going to give me 4. I've put centimeters there. I mean meters, don't I? Meter squared. So if I've got 36 meters squared, I can now take away my 4, which gives me 32 meter squared. And here it is again. So let's just go through that one more time. You are breaking up your path into 2 separate shapes. The first one is your rectangle. The second one is your parallelogram. Area of the rectangle is length times width. So 8 times 2 is 16 meters squared. Area of the parallelogram is base times perpendicular height, base times height. So that's going to be 10 times 2 is 20. As I said on the previous slide, but remember, you can see there where they overlap. So we don't want to count that middle square twice. So we work out what the area is of that middle square, and then we take it away. So the total areas of the paths is 32 meters squared. Okay, let's look at this next problem. It's the same garden, but this time we want to know the total area of the grass. Right, what do we know so far? We know that the path is 32 meters squared. We also know that the garden itself is a parallelogram. How do we find the area of a parallelogram? We do area equals the base times the perpendicular height. Area equals base times height. So in this case, our base is 10, our height is 8. So 10 times 8 will give me 80 meters squared. But we want to only know what the area of the grass is. We know what the path is already, so we need to take the area of the whole parallelogram, take away the area of the path, and that is going to leave us the area of the grass. 80 minus 32 equals 48 meters squared. So here it is again. Let's just go over that one more time. So we can work out the area of the whole garden. We can do that because it's a parallelogram, and we know to find the area of the parallelogram, you do base times height. So 10 times 8 is 80. You've already found out the area of the paths. That was the tricky bit in the first question. And we know that the area of the paths is 32 meters squared. So the garden is made up of grass and path, nothing else. So we take the total area of the whole garden, take away the area of the path, and we will be left with the area of the grass, which is 48 meters squared. Okay, let's have a look at this one. So the school garden is a rectangular shape. Use both Euler's and Mohs methods to find the total area of the garden that is made up of flowers. So Euler thinks, I will find the area of the whole garden, then subtract the area of the vegetables. Whereas Moh is saying, I will find the area of each flower bed and add them together. So let's go through both methods, and then you can decide which one you think is the best to use. So how are we going to calculate the total area of the vegetable gardens? Well, Isla says she finds the total area of the garden first of all. So we're going to take the whole square, and we know that, well, it's not a square, is it? It's a rectangle. It's 6 meters by 5 meters. So to find the area of the whole garden, we're going to do 6 times 5, which equals 30 meters squared. Then look at our two vegetable beds at the top. So we know that this distance is going to be 4 meters. How did I do that? Well, I know the whole width is 5 meters, and I know the bit at the bottom, that small vegetable bed, is a meter. So 5 take away 1 is 4. So that length there that I've marked on the screen must be 4. Now I can use my formula for finding the area of a triangle. I can do my base, which is 3, times my height, which is 4, and then divide that by 2. So 4 times 3 equals 12. Divide that by 2 is 6 meters squared. But we've actually got 2 flower beds that size, haven't we? So I can do exactly the same with the second vegetable bed that is the same size. Then I'm going to look at my vegetable beds down at the bottom. Let's do the little one first. So again, using our formula, base times height divided by 2. Our base is 1 meter, our height is 1 meter. 1 times 1 is 1. Divide that by 2, and we are left with 0.5 or a half. And then finally, our last vegetable bed. Well, this one we need to decide what our base is. If the length of the whole garden is 6 meters, and we know that the little vegetable bed is 1 meter, 6 minus 1 gives us 5 meters. Our height is still 1 meters, like the little bed. So we can say 1 times 5 is 5. We divide that by 2, and we get 2.5 or 2.5. Now, going back to what Isla said she was going to do, she said she was going to find the area of the whole garden. Well, we've done that. That's 30 meters squared. And then subtract the area of the vegetables. So I'm going to have to add up all my vegetable areas. So I've got 6 meters squared plus 6 meters squared plus 0.5 plus 2.5. So that's going to give me 15 meters squared. So going back to what Isla said, you take the whole garden, that's 30. You take away the vegetable areas, that's 15. And so you are left with 15 meters squared. Did you like that method? Does it make sense? Let's see if you prefer Mo's method. So he said he was going to find the area of each flower bed and add them together. So let's look at that big triangle first. We know the base of the triangle is 6 meters, and we've already calculated the perpendicular height. Remember, that is the tallest point from the base to the distance between the tallest point to the base, so it meets the base at right angles. We already know that is 4. So to find the area of that triangle, we're going to do 6 times 4 and then divide that by 2. So 6 times 4 is 24, divided by 2 gives us 12 meters squared. Then we've got our other flower bed. Again, our base is 4. Remember, this flower bed is just upside down, so the base is at the top. The base is 4, and our perpendicular height there is 1, because it is the same distance. It is the distance from the base up to the tallest point at right angles. So we can say that that smaller triangle, to find the area, we do 6 times 1, which is 6. We divide that by 2, which is 3. So then Mo says, after I found the area of each flower bed, I add them together. So 12 plus 3 gives us 15 meters squared. Which method did you like the best? Why have you chosen that one? Okay, let's have a look at question 2. Sophia is calculating the number of triangular tiles needed to cover her bathroom floor. So our first question is, what is the area of the bathroom floor? So if you look at that blue rectangle, what do you notice about the lengths? Hopefully you can see that the width of the bathroom is 60 centimetres, but the length of the bathroom is 1.2 metres. So what's the first thing we're going to have to do? Well, the first thing we're going to have to do is change our 1.2 metres into centimetres. Then we can calculate the area. So 1.2 metres is 120 centimetres. So we can do 120 times 60, 12 times 6 times 10 times 10, and that will give us 7,200 centimetre squared. Then it's asking, part B, is what is the area of one tile? So this is where we use our standard formula, base times height divided by 2. So we've got 30 times 30, which is going to be 900. I did 3 times 3 and then times that by 10 and times it by 10 again. We then divided that by 2, which gives us 450 centimetre squared. So how many tiles are needed to cover the whole floor? So if one tile is 450 centimetres squared, we need to work out how many of those will fit into 7,200. And we're going to do that by dividing. So we're going to divide 7,200 by 450. Now, I don't know my 450 times table, so I'm going to need to work that out. And I'm going to do this in exactly the same way as we have done for all our long division at school. So I'm going to partition my 450 into my hundreds and my tens. And then I'm just going to work out what one lot is, 2 lots, 3 lots, 4 lots, 5 lots, and 6 lots, like I've done on the screen there. So let's do our division sum. So how many lots of 450 can I get from 7? Well, I can't get any. So how many can I get from 72? I still can't get any. How many lots of 450 can I get from 720? Well, I can get one lot of 450, and 1 times 450 is 450, and then I need to take those away. I'm going to take those away. I'm going to bring down the 0. So now I've got 2,700. So how many lots of 450 can I get from 2,700? And if we look back at my times table, you can see that I can get 6 lots. 6 times 450 is 2,700. So I take those away and I get an answer of 0. So how many tiles do I need to cover the floor? I need 16 tiles to cover the floor. So on here, really my top tip is to work slowly. None of this is maths that we haven't done before. It's just you need to work out what maths you need to do. And don't be frightened that there are lots of steps. Okay, just take each one at a time and you can do it. Into your practice book. So on question 1, calculate the areas of the shapes. So this is a parallelogram. So we're going to do area equals base times perpendicular height. So just be careful with what you're putting in as your perpendicular height. It is the line that meets the base at right angles, not the diagonal line. And again, with B and C, well, B is a triangle, so you want base times height divided by 2. Again, be careful what your height is. It is the line that meets the base at right angles, even if it's a dotted line. On C, you've just got to think about what your base is for this. And what I'd like you to do is turn your parallelogram round, because 8 is the base. That should help you find the height. Question 2. These shapes have the same area. What are the missing measurements? Now, the most important thing to look at when we're looking at the first shape is to realize that that is a square. If one side is 6, that means all sides are 6. We can then work out the area of the square. 6 times 6 is 36. That will help you work out B and C. So area of a rectangle is area times length times width. So 36 equals 12 times something. Use the inverse to find the something. And you're using a similar idea for C. We know the formula for finding the area of the triangle. It's area equals base times height divided by 2. So we know what the area is, we know what the base is, we don't know what the height is, but we can still do divide by 2. So work backwards, using the inverse each time. Question 3, what is the area of the shaded regions? So in A, you're finding out what that area is of the small triangle. We're just using our standard formula. Area equals the base times the height divided by 2. Whereas on B, you now have to work out the area of the rectangle, and then you take away, and that's the small triangle. S is for small, and that was supposed to be a triangle. Question 4. A room is 5 meters long by 3 meters wide. It costs £255 to carpet the room. How much does the carpet cost per meter squared? So find out the area of the room and then divide your total cost of the carpet by however much the area is. Question 5. The area of the triangle and the area of the parallelogram below are equal. The area of the whole shape is 60 centimeter squared. What is the length of the base of the parallelogram? So if we know that the area of both are equal, but together it is 60, then we know that both are 30. We know more about the triangle, so let's start with that one. We can work out, we know that the area is 30, we know the base is 10, we don't know the height, but we know that we have to divide it by 2. So again, you can use the inverse to work that out. Once you know what the height is, you can do the same for the parallelogram. If you want more practice, there are some more questions there. If you fancy a challenge, you've got those there. And then we can finish today's lesson by just reflecting on that last statement. So write down 3 facts that you have learned about area in the last few lessons. My top tip for today's lesson is do one question, come back to the video. Keep coming back to the video to help you along the way. Have fun today. Bye.